All right, in this video, we're using the laws of exponents to simplify each expression. So let's remember that when we raise a term to a power, we multiply the exponents by one another. So this 4 is to the 1 power and the 5 is to the 1 power. So when we distribute in this 2 here from the outside, it's going to become 4 squared there. So it'll be 4 squared. Bringing in the 2 to multiply by this negative 2 is going to give you x to the negative 4th power. And then we bring the 2 outside to multiply by the exponent on 5, which is going to give us 5 to the 2nd power. And then lastly, we're going to bring that 2 in to multiply by the negative 1, and it's going to give us, therefore, y to the negative 2 power. Okay, so with that taken care of, the only thing we have to do now is evaluate the exponents that are on the numbers. So 4 squared will be 16, and 5 squared would be 25. And then lastly, we want to make sure we don't have any negative exponents in our answer. So we're going to want to take this y squared, for example, or y to the negative 2 power, I should say, and bring it up to make it y squared. So when it ends up on top, it'll change the sign of the exponent. So remember, if you pick up the term and move it across the fraction bar, you change the sign of the exponent. So if I were to bring this x to the negative 4 down below, it's going to become just x to the 4th power. All right, so that's my answer then for this problem. The simplified form is 16y squared divided by 25x to the 4th. Okay, good. Let's tackle problem B now. So looking at problem B, first thing I want to do is bring this exponent of 5 into the parentheses here. So I'll rewrite that first piece as x to the 4th times, now 5 times 3 is going to give me x to the 15th power. Then I'll have times y to the 5 times 2 power, which is going to be the 10th power. That's my numerator. I'll draw the fraction bar and then write my y to the 12th at the bottom. Okay, from there, I'm going to use the rule that says when multiplying two terms with the same base, we add the exponents. So it's going to be x to the 19th power because we keep the base and add those exponents. Then we'll have y to the 10th divided by y to the 12th. All right, from here, what we want to do is perhaps bring the y to the 10th down below to be with the y to the 12th. And when we do that, we're going to end up having x to the 19th on top of the fraction divided by, on the bottom, y to the 12th times y to the negative 10. Remember, when we bring an expression or a piece of the expression down below the fraction bar, we end up having the exponents become the opposite sign they were. So it was positive 10, on the bottom it'll be negative 10. Now using that rule that says when multiplying two terms with the same base, we keep the base and add the exponents. In this case it'll be 12, minus 10, which gives us 2. And on the top it's x to the 19th. So there is the simplified form of expression B. All right, the last one we're going to work out then is C here. And we'll do the same thing we did before. We're going to work the problem out by starting by eliminating this parentheses. So we're going to bring in the 2 into each piece. Now remember, the little 2 inside the parentheses has an exponent of 1, so it's 2 times 1 to give you 2 squared there. And then the x has an exponent of 1, so it'll be 2 times that as well, giving you x squared. And then the 2 comes in to multiply by the 3 on the y, giving you y to the 6th power. Then in the remaining part of the numerator, we have x to the 5th and z to the negative 1 power. So all that's in the numerator, and in the denominator, we simply have y to the 1 power and z to the 1 power. All right, with that, we're going to begin to essentially combine things that have a common base. So the 2 squared is simply 4. The x squared on top with the x to the 5th are going to multiply. We're going to keep the common base and add the exponents to get x to the 7th. Then we'll have y to the 6th, z to the negative 1 power, all over again, y to the 1 and z to the 1 power. All right, from here, we want to get the y's and the z's together. So let's bring the z to the negative 1 down because it has a smaller exponent than the one on the bottom. And when I do that, I'm going to end up with on top 4x to the 7th y to the 6th. And my z will now be at the bottom with the others, so it'll have y to the 1, z to the 1, and z to the 1. Remember, when it crosses the line, it changes the sign. So we'll be multiplying those z's together. Now let's just finish this up in one more step. I'm going to write it then as 4x to the 7th. Now with this y to the 6th, I realize that I'm dividing in the denominator by a y to the 1, so the y to the 6 and the y to the 1 can be simplified to say 6 minus 1, or in other words 5. Remember, when you're dividing two terms with a common base like this, we're going to subtract the exponents. So it's y to the 6th minus 1 becomes y to the 5th. Now in the denominator, I move that z down, so now I have two z's multiplied. Since they have a common base, we'll keep the base and we'll add the exponents. It's going to become z squared. So in the end, this is our final simplified expression. It's 4x to the 7th, y to the 5th over z squared.